Good evening, students.
Good evening, sir.
Good evening.
Good evening, beta. So, in the last class, I was discussing Bohr's postulates. Bohr's postulates. So, we have already discussed two postulates. Now, third Bohr postulate. So, basically, electron is revolving around the nuclei. What this postulate is saying, this is the nuclei, positively charged nuclei. And this electron, it is revolving around it in a particular circular or in some certain circular orbit. So what it says that out of infinite number of orbits which are possible in which this electron can revolve around the nuclei. So there are infinite possibilities. So out of infinite orbits, ठीक है ना, which are possible in which this electron can revolve around the nuclei, only those orbits are possible. ठीक है ना, only those orbits are possible for which angular momentum is n times h cross. So what they are saying that suppose electron is revolving in this orbit and radius is r, it is moving with the velocity v here, mass is m, then only those certain orbits are possible for which mvr is equal to n h upon 2 pi. ठीक है, n h upon. So all the infinite possibilities are there, but all the orbits are not possible. So out of infinite possibilities, only those orbits are possible for which angular momentum mvr that will be equal to n is some integer n times h cross or h upon 2 pi. Only those orbits are possible. How he find out this one? So in the last class I told you when electron is revolving in a certain orbit and it is not radiating energy, it means why it is happening, why it is possible, because when this electron, this is a quantum particle, when it is revolving in this orbit, basically its wave nature is coming into the picture, and that wave nature that is creating a stationary wave structure around in this orbit. So when electron is revolving, actually it is exhibiting its wave property, and this due to this wave property, a stationary structure is formed in this orbit. So for this 2 pi r, ठीक है, this will be how much? This will be n, ठीक है, n
Lambda.
and lambda. This will be n lambda. ठीक है. Now, what is lambda? If you are talking about the wave property, then for this wave property lambda, that will be equal to how much? H upon p or h upon mv, you can say. ठीक है, lambda will be equal to h upon p or h upon mv. Substitute here. So this will be n will be here, h upon mv, and this will be 2 pi r. 2 pi r. So bring this mv on the left hand side. So this will become mvr, and this will become n h upon 2 pi. So from this understanding that some type of stationary structure is formed in this orbit, ठीक है, he find out that these orbits, they are quantized. ठीक है, only though this is called as the quantization of angular momentum, or you can say only those orbits are possible for which angular momentum is integer multiple of h upon 2 pi. So N may be 1, 2, 3, 4. So corresponding to n equal to 1, there will be some velocity v1. There will be a particular radius r1. For n equal to 2, it will be r2, it will be v2. So in general, we are going to write mvn, rn, and this will be equal to nh upon 2 pi. And this is called as quantization of angular momentum. So angular momentum is quantized here. Here, angular momentum is quantized. Okay? So you can write here out of infinite possibilities, you can write here out of infinite possibilities of orbit, out of infinite possibilities of orbits in which in which electron can revolve around the nuclei, in which electron can revolve, in which electron can revolve around the nuclei, around the nuclei classically, around the nuclei classically, comma, only those orbits, comma, only those orbits are possible, only those orbits are possible for which, only those orbits are possible for which, or the magnitude of, for which, the magnitude of orbital angular momentum, for which the magnitude of orbital angular momentum, orbital angular momentum is an integer multiple of, is an integer multiple of h upon 2 pi, is an integer multiple of h upon 2 pi. So you can write mv and rn equal to nh upon 2 pi. mv and rn equal to nh upon 2 pi. Here, here, Bohr introduced the quantization of angular momentum. Here, Bohr introduced the quantization of angular momentum, quantization of angular momentum, which will, yeah, which leads to, which leads to, which leads to, which leads to quantization of energy, which leads to quantization of energy finally, which leads to quantization of energy finally, which leads to quantization of energy finally, beta, finally. So, is it okay, beta? So these three postulates he introduced. Now, on the basis of these postulates, whatever he is telling in these postulates, on the basis of these postulates, he find out various formulas for the radius of these orbits, velocity of the electron, ठीक है ना, velocity of these electrons when they are revolving in n equal to 1 orbit, n equal to 2 orbit, energy of the electrons, ठीक है ना, in different different orbits, potential energy, kinetic energy, ठीक है. So all these formula he derived on the basis of these three postulates, and these formulas are quite good with one electron system. In case of one electron system, these formulas are quite good. So next, you can say first nuclear radius, sorry, not nuclear radius, sorry, radius of, just radius of nth orbit, radius of nth orbit. So first is quantization of angular momentum is there, mvn rn. This will be n h upon 2 pi. nh upon 2 pi. So from here we can write Vn. Vn will be how much? This will be nh upon 2 pi m into Rn. This will be Vn. Okay? This is not the formula of Vn, but this is Vn. From here I find out. Now, next is Bohr is saying that electron is revolving in certain discrete orbits around this nuclei. So electron is revolving in these circular orbits, and he's saying that classical equation of motion is valid here. Classical equation of motion is valid here. ठीक है, लिखे बेटा. As electron is revolving around the nuclei in a circular orbit, as electron is revolving around the nuclei in a circular orbit, so there should be some source. So there should be some source of centripetal force. So there should be some force of centripetal force. So centripetal force that acts toward the center. Centripetal force that is going to act on this electron when it is revolving, it is going to act toward the center. So there should be some force that should act toward the center, and that force will actually act as centripetal force. So what is the source of this centripetal force? mvn square upon rn. When this electron is revolving in the nth orbit, this will be the centripetal force. From where this centripetal force is coming into the picture? By the electrostatic attraction between the nuclei that is suppose carrying plus Ze charge. Okay? Because we are talking about one electron system. For hydrogen, Z will be 1. For helium ion, this will be 2. For lithium ion, this will be 3. It will be like this. So that's why I'm writing it as plus Ze. So what it will be? That will be 1 upon 4 pi epsilon naught. That will be Ze into E. This Ze Q1, Q2. So this will be Ze square. You can write upon this Rn square. Z square upon Rn square. I have used the formula 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Coulomb's law. Okay? Coulomb's law I used. Now substitute this Vn from here. Substitute this expression here. So this will be m upon Rn will be here. And this will be n square h square upon 4 pi square m square, and this will be Rn square. On this side, this will be 1 upon 4 pi epsilon naught Ze square upon Rn square. So now if you look at this Z Rn square, this will be cancelled out. 1m, it is going to cancel out. So what will be this Rn? What will the formula bring this Rn on this side? So what will be Rn? Rn will be, this will be 4 pi epsilon naught n square h square. This is the exact formula in SI system upon 4 pi square m e square, ठीक है ना, and z, e square z. So this is the exact formula of this radius of the nth orbit. This will be, ठीक है ना, this is the exact formula. Here, if you consider, ठीक है, try to understand, for hydrogen atom, if electron is in n equal to 1 orbit, if electron is revolving in the n equal to 1 orbit, then what will be the radius? Substitute here. So that will be equal to, what will be the radius? That will be equal to 4 pi epsilon naught. 4 pi epsilon naught. N is 1, so this will be n square h square. This will be n square. एक मिनट बेटा, हाँ ठीक है, n square h square, नहीं इसे मैं ऐसे लिखता हूँ, n is 1, so 4 pi epsilon naught h square upon 4 pi square m and e square. This is called as Bohr radius. You represent this by a naught. This is the radius of n equal to 1th orbit in the hydrogen atom. What you call it? You call it as Bohr radius. This is called as Bohr radius. Bohr radius means radius of n equal to 1th orbit in hydrogen atom. Bohr radius, this is called as. And what is its value? If you look at this formula, every quantity that is a constant, 4 pi epsilon naught is a constant, h square, 4 pi square, m e square, they are all constant. If you substitute all these values, you will find out 0.52. 0.52, ठीक है ना, angstrom. Now, substitute this, ठीक है ना, substitute this value, this expression here. So what will be Rn if I substitute this 4 pi epsilon naught h square 4 pi square m e square, I replace this by a naught, then what will be Rn? Rn will be Bohr radius a naught, this n
N
square is
square
there,
upon Z.
n square upon z. So you have to remember, if you want to solve the question, you are going to remember this. You will remember this question. ठीक है ना? This formula, sorry. So this will be where our A naught, that is 0.52 angstrom. So in numerical problems, you can use this formula. ठीक है ना? That will make calculations very simple. So this is the formula of the nth orbit. ठीक है ना? Nth orbit in one electron system. In one electron system. Is it clear? So this is radius of the nth orbit. Now, please note it down quickly. Next button. Next is velocity of the electron.
Sir,
Yes, beta.
what means previous slide?
Okay, beta. Velocity of electron in the nth orbit, yeah, in nth orbit. When electron is revolving in the nth orbit around the nuclei for one electron system, what will be its velocity? What will be the velocity of the electron? Is it okay, beta? Can I go to the next one?
Okay, sir.
So, how can you find out? You have written this formula mvn rn. This is n h upon 2 pi. So what will be Vn? We are interested in Vn. So this will be Nh upon 2 pi m and 1 upon Rn. It will be. Now what is 1 upon Rn? Substitute this expression of Rn here. So this will be Nh upon 2 pi m. कितना होता है बेटा? बोलो 4 pi. Now we have just calculated 4 pi epsilon naught n square h square upon 4 pi square m e square z. This will be. This will be better. So what it will be? 2 pi will be left here. You are going to have 2 pi here. This m will cancel out. This nh, that is going to remove these powers. So how much is left here? 2 pi. So this h upon 2 pi, that will be h cross. So what I'm writing, I'm writing it like this, e square. E square is this, okay? Upon 4 pi, epsilon naught is there. And this is h, and this is 2 pi here. Here I'm combining this h with this 2 pi, so this will be h cross. ठीक है. Now one Z is left. Z is left. So what I do here, I write C here and C here, and N is left here. So Z and N, this Z and N, I'm writing Z by N, and this H upon 2 pi, I'm writing H cross. ठीक है. And C, I multiply denominator and numerator by C. Why I'm doing this? This is a constant that is called as fine structure constant. ठीक है. This is called as fine structure constant alpha. So I can write it as Z. Z is here. This is called as alpha. This is a constant. Z alpha C by N. This will be Vn. This will be Vn, beta. Velocity of the electron in the nth orbit. ठीक है. Where this
Sir,
alpha, yes, beta, please.
so will there be 2 pi?
2 pi is here, na? This H is there. This 2 pi is here. ठीक है. So this H cross is here. What is H cross?
Okay, sir.
H cross is actually H upon 2 pi.
H upon 2 pi.
ठीक है. Where this alpha, that is, you have to remember its expression. याद रखना है बेटा, E square upon 4 pi epsilon naught H cross C. In many books, you are going to find out E square upon H cross C, that is in quotient system. So expression for this fine structure constant is E square. In SI system, it is E square upon 4 pi epsilon naught H cross C. ठीक है ना? Is called fine structure constant. Fine structure constant. And its value is always equal to 1 upon 137. This is a constant. Its value is 1 upon 137 beta. So for velocity, you are going to remember this formula. For radius, you are going to use this Rn equal to A naught. Okay, this one here I have calculated this. This is Rn equal to A naught n square upon Z. And for Vn, okay, but what is difference here? Try to understand. If you look at A naught here, in A naught, this mass is there. This mass is there. Okay, but here mass is not present. A naught n square upon Z. Okay, so here this is mass dependent. This depends upon the mass of the electron. But here, if you look at, and here this velocity of the electron in the nth orbit, it is independent of the mass of the electron. Here you can write velocity of electron in the nth orbit. Velocity of the electron in nth orbit is independent of the mass of the electron. Is independent of the mass of the electron. Is independent of the mass of the electron. ये mass of the electron के independent होता है बेटा. It is independent of the mass of the electron. It is like this.
So,
Yes,
Sir,
beta,
it is
please.
so what is the physical meaning of fine structure constant?
अभी बेटा बाद में पता चलेगा. Fine structure constant, actually that is a very important parameter. ठीक है. Later on, when we will discuss fine structure spectral lines, ठीक है ना, then we are going to find out this one. So it is used in atomic physics. This is very important parameter, but later on it will be there, not right now.
sir, velocity of the electron is proportional to the mass of the electron.
Where it is
He said
independent
it's
of.
not proportional.
No, it's not proportional. Velocity of the electron in the nth orbit, ठीक है ना, it is independent of the mass of the electron. It is not appearing anywhere. If you look at the formula of alpha, this is E square upon 4 pi epsilon naught H cross C. This is C is a constant, Z is a constant, N is a number. So it is not appearing anywhere here. You can look here. There is no mass. M is cancelled out. So velocity of the electron in the nth orbit is independent of the mass of the electron. Okay. Later
Okay,
on,
sir.
it will have its consequences when when I am going to introduce the reduced mass here, when you are saying that mass of the nuclei is finite, then we have to use reduced mass concept here. And because mass is not appearing, so even if nuclei is of finite mass, even in that case, velocity is not going to change. Either you consider nuclei of infinite mass or finite mass, which quantity is not going to change? That is this Vn. Vn is not going to change because it is independent of the mass of the electron. It is independent of the mass of the electron. Okay? It is independent of the mass of the
Okay,
electron.
sir.
So this was the velocity. So we have find
Sir,
out
doubt.
Yes, beta, boliye please. I'm
Sir,
listening.
what is the velocity of the electron revolving around this hydrogen atom?
Yes.
Sir,
Yes, please.
not velocity. So, what is the momentum of the electron?
Momentum of the electron. What will be that one?
MBR.
That will be angular momentum. MVR will be the angular momentum. What do you mean
Sir,
by momentum, beta?
so it's only have angular momentum.
No, if it is having velocity, it will have some momentum. It surely will have momentum, but कितना होगा momentum
So I
at
mean components of the angular momentum in this case.
in which direction you are talking about?
Yes, sir.
In which direction angular momentum will be, so that you are interested in components. Try to understand. This electron, suppose this is my nuclei, and electron is revolving around it in the circular orbit. Okay? This is electron. Electron is carrying some mass. So what will the direction of it? Angular momentum. ठीक है बोलो बेटा. What will be the how you find out the direction of angular momentum? Angular momentum is an axial vector. So what you have to do, you are going to curl your fingers in the direction in which this mass particle is revolving. So you are going to curl your finger like this, okay? And this will be the direction of angular momentum. Okay? In this direction, perpendicular to this orbit, that will be L vector. Now, in which direction you want its component?
Okay, sir.
Good. So basically, इसके component नहीं है. This is axial vector. It will be along the classically it is along this axis of rotation. ठीक है ना? Axis of rotation के corresponding होगा. So now next is energy, beta. Different type of energies. Kinetic energy. That will be potential energy, beta. And then total energy. I want to find out this. ठीक है? We want to find out kinetic energy, potential energy. ठीक है? Every value I want to find out. ठीक है? बताओ how you are going to find out. Suppose you want to find out kinetic energy. For example, what will be kinetic energy? When electron is revolving in the nth orbit, that will be 1 by 2 mass of the electron, and that is Vn square. ठीक है? What will be this mvn square? Mvn square you can write upon r. You know that it will be equal to, for Rn, this is equal to 1 upon 4 pi epsilon naught Ze square upon Rn square. So 1 Rn, it will cancel out and it will be this one. ठीक है ना? It will be this one. So what will be the kinetic energy? I am going to write 1 by 2. 1 by 2. ठीक है? And in place of this mvn square, I can write this 1 upon 4 pi epsilon naught. ठीक है? Ze square upon Rn. Ze square upon Rn. Is it okay? ठीक है बेटा. तो ये now substitute the value of Rn. Substitute the expression of Rn here, beta कितना होगा? I'm substituting here. This will be 1 by 2. 1 upon 4 pi epsilon naught. Z square is already there. And substitute this. So this will be how much it was? 4 pi epsilon naught n square h square into 4 pi. ठीक है ना? This will be 4 pi square m e square z. E square z. देखना बेटा यही होगा ना? So this will be 2. 2 will cancel out. So this will be 1 upon 4 pi epsilon. Yeah, I can write like this. This will be कितना होगा? This will be 2 pi square. 2 pi square m e to the power 4. And it will be, where is one z is here, another z is here. E to the power 4 z square upon 4 pi epsilon naught whole square. And this will be n square h square. This is the kinetic energy. This is the kinetic energy. ठीक है? If you find out potential energy, how much it will be? This will be potential energy. I can write these in very simplified form very soon. UN कितना होता है? What will be UN? Potential energy. Because this is a bound state, potential energy कितना होगा? Negative होगा. This will be, बोलो, 1 upon 4 pi epsilon naught Q1 Q2 upon R. So that will be Z E Q1 Q2. ठीक है? Potential energy will be negative here. ठीक है? This is a bound state. ठीक है? One particle here, nuclei is positively charged, electron is negatively charged. ठीक है? So one एक Q1 जो है, one will be positive, another will be negative. So I'm writing minus sign here. That will be ZE square upon Rn. Look here, this is half of this. ठीक है ना? Kinetic energy. So what is this? Potential energy, if you look at, is number है. If you look at this quantity, that is 1 by 2 here. So that will be 2 times of this. Whatever this formula is with negative sign, it will become minus 4 pi square 2 times m 4 pi square m e to the power 4 z square upon 4 pi epsilon naught whole square n square h square. That will be. Now, what will the total energy of the electron in the nth orbit? That will be the sum of these two. So En, En, if you look, that will be the sum of this is, if you look at this is 2 pi square, this is with minus sign 4 pi square. So what will be total energy of the bound state here? Negative energy will be there, and that will be 2 pi square m e to the power 4 z square upon 4 pi epsilon naught whole square, and this will be n square h square. This will be En. This is the exact expression of the En in SI system. So whatever I'm using here, I'm doing all the calculations in SI system. In few books, you may find out these calculation in SI system. They are older books following older pattern, but in India, the exam pattern is based on SI system. So that's why I'm using all these formulas in SI system. So this is En. So En is how much? Here, if you look at En is minus why? Because this is a bound state. This electron is bound to move around the nuclei in a certain orbit. It is bound. You have to provide energy from the outside, only then it will move out of the clutches of this nucleus. ठीक है? So you have to provide external energy from the outside source so that you can break this system. Okay? You can remove this electron from from the from the clutches of this nuclei. So En will be equal to minus 2 pi square m e to the power 4, and I'm writing, chalo first I write formula here, upon 4 pi epsilon naught square n square h square. If you look at these formulas, what you are observing, you will observe that this En, if you take the mode of this En, this will be equal to kinetic energy. Okay? Numerical value of En and kinetic energy is same. Okay? Kinetic energy is positive. Here, this total energy is negative. So this will be. If you look at this potential energy, UN, ठीक है? UN कितना होगा? In terms of, sorry, I should write like this. I should write like this, that kinetic energy, it is equal to En. In this way, I should write. What will be potential energy? That will be 2 times En. 2 times En. Okay? So this is the correlation between kinetic energy, potential energy, and total energy. Total energy. You have to remember this. Next thing is, look at this En. I want the simplified version. Every time I'm not going to use this formula. So En, if you look at this minus sign I'm writing here, and this is 2 pi square m e to the power 4, and I'm writing z square here. Z square here. Okay? And it will be 4 pi epsilon naught square n square I'm writing here, and this is h square. So what I do here, I'm writing h cube here. So 1 power I have raised. This is 2 power here. I raised 1 power. And so I'm writing h here. And I multiply here by c. So I'm introducing c here. So if you look at this, this is a constant. If you look at this, this is a constant that is called as Rydberg constant. What is this? This is the expression of Rydberg constant. You call it as R infinity. R infinity, this is 2 pi square m e to the power 4 upon 4 pi epsilon naught whole square, and this will be h cube c. This is R infinity. ठीक है? This will be Rydberg constant. Remember, याद है बेटा मैंने last class में बताया था? What is its value? What is its value? 0.9
1.09 10 to the power 7 angstrom.
into 10 to the power 7, not angstrom, meter inverse beta
Yes,
number.
sir.
Okay, that will be meter inverse. So this will be R infinity. So I can write like this, that this En, this is minus R infinity HC upon n square. I am writing here, this will be Z square. Okay, this is called as Rydberg constant. And this R infinity HC, this is called as 1 Rydberg. This is not Rydberg constant. This is Rydberg constant is R infinity. But this is sometimes it is this is used 1 Rydberg or 2 Rydberg. So that means 1 Rydberg means R infinity HC. And what is its value? कितना value होता है? 13.6 electron volt. ठीक है? It is 13.6 electron volt. This is called as 1 Rydberg. ठीक है? So En if you write here for 1 electron system, that will be minus 13.6 upon n square. And this will be Z square. And this will be in electron volt. This will be the energy of the electron in the nth orbit. So this is the expression that you are going to use. Okay? This expression you are going to use. Next. Sometimes they use term value of the state. This is the energy of the state. Try to understand, this is the energy of the state. Sometimes they are going to use term value of the state. In numericals, you will find out this term value of the state. This is represented by Tn. Term value of the nth state, that will be how much? Minus En upon Hc. So if they are using term value, it means that will be this, and this its unit कितना unit होगा बेटा इसका? Can anyone tell me? बोलो बेटा. What will be its unit? Meter inverse. भाई energy का energy क्या होता है? Hc upon lambda. So Hc will cancel out 1 by lambda. So that will be meter inverse. ठीक है? Or they may give you numbers in centimeter inverse also. So this is called as the term value of the state. Sometimes they are talking in terms of energy of the state, that will be negative. But term value, that will be positive. Its expression is minus En upon Hc. So if they are providing you term value, so don't worry. If term value, substitute that value here, multiply this by Hc, bring minus sign here, that will be En. So if you know the term value, you can always find out the energy of the nth state or any another state. ठीक है? This is the energy beta. Now, next is orbital frequency of the electron. Next is orbital frequency of the electron. Frequency of the electron. Electron revolving in nth orbit. Revolving in nth orbit. So what do you want to find out? Or what is the meaning of orbital frequency? It means in 1 second how many complete revolutions electron is making. ठीक है, number of revolutions per second you want to find out. You can write here orbital frequency means number of revolutions per second. Number of revolutions per second. ठीक है, how many revolutions it is completing in 1 second. So what it will be? कितना होगा बेटा? That will be, you can say that Fn, that will be 1 by Tn time period. ठीक है ना? Time taken by the electron in completing one circular orbit in one complete revolution. So ये कितना होगा? What will be Tn? This will be 2 pi Rn divided by Vn. So I'm writing Vn here. I'm writing Vn here. ठीक है, तो मैंने Vn इधर रख दिया बेटा. अब Vn का फॉर्मूला देखो कितना था, मुझे याद नहीं है. Vn का याद नहीं क्योंकि Z alpha C. I just look at this formula. This will be 2 pi Z square. 2 pi Z square upon NH. Please, this will be 1 upon 2 pi into 2 pi Z square into NH, or 4 pi epsilon naught is also there. With this 4 pi epsilon naught is also there. That is okay. इसका जरूरत नहीं पड़ता है, सो याद नहीं रखता मैं. दिस Rn कितना होगा? Rn will be 4 pi epsilon naught. N square H square. ठीक है ना? 4 pi square N square H square, and this will be Rn was 4 pi. This will be 4 pi square M E square Z. ठीक है ना? E square Z. So just check it. ठीक है? So these values are there. So you want to find out this. So if you look at this 2 pi, this 2 pi is going to cancel out here. This is 4 pi epsilon naught. I'm bringing this 4 pi epsilon naught here, square here. ठीक है, this h and this h cube here. This n cube I am writing here, n cube here. And this will be 4 pi. I am splitting it. I am writing it 2 times. And this will be 2 pi square. 2 pi square m e to the power 4 and z square here. Z square. So what is missing here? This is the expression of Rydberg constant. So I multiply here. C is missing. So I'm writing C here. So what is this? This will be 2 times R infinity C upon n cube into Z square. This is the formula of the free orbital frequency of the electron in the nth orbit. What you have to remember here? Formula you can remember, but remember this Fn is inversely proportional to n cube particularly. तो ये हमें जरूर पता होना चाहिए. And Fn is proportional to Z square. There may be a numerical on the basis of this orbital frequency. ठीक है ना? There may be a numerical on the basis of this frequency. Is it clear? Now,
Yes, sir.
next. Suppose this is n plus 1th orbit and this is nth orbit, and n is very very large, means n is very very large as compared to 1. N means n is very very large. Suppose a electron jumps from here to here, then it will emit a photon. ठीक है, it will emit a photon, h nu. ठीक है. So now look at this h nu. What will be this h nu? This h nu will be how much? This is high energy level, so you are going to write it as En plus 1 minus En. Sorry. What will be En plus 1? This will be minus R infinity Hc upon n plus 1 whole square Z square minus this minus. इसका एनर्जी कितना होगा? That will be minus R infinity Hc upon n square, and this will be Z square. So this minus minus plus, and I can take this R infinity Hc, and this Z square common. And here this is h nu. And in bracket, what you are going to have, this is minus minus plus. This will be 1 upon n square minus 1 upon n plus 1 whole square. So h will cancel out. So what will be nu? Nu will be R infinity C, and this will be Z square. Here it will be n square and n plus 1 whole square. And on this side, this will be n plus 1 square minus n square. N square. So what it will be? How much it will be? R infinity C Z square. This will be n plus 1 square minus n square. So this will be 2n plus 1. What will be its factor? 2n plus 1. And that will be 1. ठीक है ना? A plus B is 2n plus 1. A minus B. This will be 1. Divided by this n square and n plus 1 square. Now n is very, very large. When electron, here what is happening, electron transition is taking place into 2 successive levels when n is very, very high. When n is very, very high. In that case, frequency of this photon emitted frequency of this photon emitted, this nu we are calculating. So here, apply this condition, n is much, much greater than n is very, very large. So this one can be, you can neglect this one can be neglected here. So this will be 2n upon n to the power 4. So 1n will cancel out. What is the frequency of this photon? That will be 2 times r infinity c upon n cube. And this will be z square. So when electron transition is taking place in between two successive energy levels, okay, where n number is very, very high, then this will be the frequency. This will be the frequency between, okay, and this will be the frequency. So remember this, there may be, this is, actually this is coming exactly, if you look at this, this is exactly coming out to this orbital frequency. This is coming out to be the orbital frequency. Sometimes this type of question they may create where, but they are different frequencies. Remember this, here electron is revolving in nth orbit. Then how many cycles he is completing, how many revolutions it is completing in 1 second, that is orbital frequency. So during its orbital motion, number of revolutions completed by electron in 1 second is orbital frequency, that is this one. But this expression is exactly same. You will find out it exactly same when electron transition is from in between two successive levels. This is n plus 1, this is n. And a photon is emitted. Then you will find out the energy of this photon. Sorry, frequency of this photon is exactly equal to this. 2 r infinity c by n cube into z square. Into z square. This will be. ठीक है, this will be the frequency. So थोड़ा आज बेटा छोटा ही क्लास लेते हैं. Actually, I have to introduce the aspect of this two body problem. I want to convert two body problem into a single body problem if we consider the mass of the nuclei finite. So it will not be completed here. I have a next class at 9:30. So I'm stopping here today. In the next class, I will complete this chapter and then I will discuss numericals. Very few aspects are left. First, I will discuss those aspects and then I will start discussing numerical problems. But here, during this, all these derivations, that question is left unanswered. That only 5 series are there. Why
Sir,
only?
can you repeat the last equations? Means r infinity c z square twice n
Yes.
plus 1 into multiply 1 divided by n
So
square.
actually n is much, much greater than 1, beta. N is like 1,000 or something like 500,000. So if this is 1,000, it is 2,000 plus 1. 1 can be neglected here. Okay? Similarly here, this is 1,000 plus 1. So approximately you can cancel this one. When n is very, very large, I have started this derivation with this. It's not always. You cannot choose 3 and 4. Then this formula you are not going to get. You're going to get exactly the formula that is for orbital frequency in case if transition of electron is taking place in between two successive level, and when level is very high, n number is very high for those levels. In that case, that frequency of the photon will be exactly equal to this. ठीक है ना? That is
Okay, sir.
exactly equal to this. Now here, so in the last class, there was a question that why five series are there. So still, even after observing this, all these calculation, you cannot find out your answer. You will not find out your answer that why 5 series are there. Actually, for this, a lot of development take place. People continue their work. ठीक है ना? They continue their work. And later on, this this theory was completely developed on the basis of quantum mechanics. In quantum mechanics, there is a chapter hydrogen atom problem. In hydrogen atom problem, you are going to find out everything with the help of Schrodinger equation. You are going to solve the Schrodinger equation. You are going to find out the wave functions for the electron for different energy levels corresponding psi n. You are going to calculate, En you are going to calculate. And then you find out one term that is called as transition probability. ठीक है ना? That is called as transition probability. So experimentally, what we were observing that only 5 lines, 5 series are there. 6 was not there, but from Bohr model, it appears that 6 should be there, 7 should be there, 8 should be there, but they are not there experimentally. So why they were not there? Its answer is not here in this theory. Later on, when you are going to study in quantum mechanics hydrogen atom problem, then you will find out the expression for transition probabilities. And you will find out transition probabilities, they are zero. Transition probability for other series which are terminating at n equal to 6, the transition of electron, ठीक है ना, those transition which are terminating at 6, 7, 8, 9, you will find out their transition probabilities are coming out to be zero. So with the help of this model, you cannot answer that question. You can answer that question a little bit later when you are going to study quantum mechanics. So that is on the basis of transition probability you can. So that comes out to be zero. ठीक है? So transition probability, when you can calculate wave function, after wave functions, you can find out transition probabilities. And that comes out to be zero for this. चलिए बेटा आज यहीं रुकते हैं. Thank you very much.
Thank you, sir.
Thank you,
Welcome
sir.
बेटा.
sir.
Thank you, sir.
Welcome बेटा.